still is connected to the correct kernel. So it should say R conda M GL4U -R in the top right hand corner, and it should say idle in the bottom left. So if anybody does not see that, let me know. And then finally, I would like everyone to please add a cell and confirm that you are still in your home directory. So in this new cell that you've added with the plus sign, please type get WD, open close parentheses, and go ahead and run that cell. So the output should be home/Debian. And I've started recording. All right, so is anybody not in the right cell, in the right kernel, or does anybody not see that they're in their home directory? Okay, great. So let's go ahead and get back to looking at the first few lines of a data frame that's held in a variable. So the way that we do that is using the head function in R, open close parentheses, of course, since this is a function, that's the syntax for functions in R. We pass in the variable holding our data frame, and then a comma, and then the number of lines that we want to see, and n equals the number of lines we want to see. So in order to print the first 8 rows of the data frame, we would run head mydf, comma, n equals 8. That cell. So if anybody does not see how I got here, please shout out, and I can go over that again. Any questions about the head function? Okay, great. All right, so another way that we can process a data frame and look at different aspects of it is this new function called dim, which stands for dimensions, and will allow us to print out the dimensions of the data frame. So remember, originally when we printed out our data frame back up here, we asked how many columns and how many rows, and we could just look and see, we could count. And it's extra helpful because I named the columns with the numbers and the rows, so it's easy. But as I mentioned, with RNA sequencing data, we can often have 30 to 50,000 rows and hundreds of columns. So it's sometimes nice to be able to just look at a summary of our data frame on the dimensions. And so we can use the dim function. This is just like head, where we just pass in the variable that holds our data frame. And so we can go ahead and run this cell. So I'm going to let you guys run it and let me know in a poll that I'm going to set up, is the row or column dimension reported first when we use the dim function? All right, so I've opened the poll. Go ahead and run this cell, dim mydf, and let me know, is the row or the column dimension reported first? Still waiting on a few more people here. Run this cell and let me know, is the row or the column dimension reported first? for the dim command. Okay. Let's go ahead. And just as a reminder, all instructors, please make sure to answer the polls since I can't always see who has answered. So in just a couple of seconds to give the last few people a chance to answer, I will close the poll. Okay. All right, so is the row or the column dimension reported first? All right, we have a mixture of answers. So let's go ahead and run this. So when I run dim mydf, I get 10 first, and then I get 3. So these are the dimensions of the data frame. We know that our data frame has 10 rows and 3 columns. So the row dimension is being reported first. All right. Any questions from anyone on the dim section? All right, great. All right, one more nice handy function that we can use to get more information about a large data frame is the function called summary. So, and the reason we're going through all of these functions is because we're going to use all of them to kind of interrogate the data frame of gene expression data that we get at the end of processing before we do the analysis. So getting familiar with them now. So to get more information about a data frame that has been loaded into R, maybe it's held in a variable, without having to print that entire data frame out, we can use the summary function. And this is a function in R that prints a mathematical summary of the data frame. And so a quick note, summary isn't just for data frames. It can be used on lots of different data structures and objects in R just to report all the different data components. But when it's run on a numerical data frame, it will perform mathematical operations. And it'll give us a summary, mean and median and max and min and so on and so forth. So I think you guys are getting the hang of how we run functions on variables that store data. So I'm going to let you go ahead and figure out the syntax to run the summary function on your mydf data frame. So I'll give you a hint. All that needs to be passed into the summary function is the variable holding the data you want a summary of. That's it. So go ahead and figure out that syntax. And then I'm going to put up a poll where I'm going to ask you to share the syntax you used and then which column contains the highest median value in our data frame and which column contains the highest overall value. All right, I'm going to go ahead and close the poll. All right, let's see here. All right, so we have a few different answers here. Yep. All right, so let's go through this together. I'm seeing a lot of right answers. So just like dim or head, a lot of these functions we've been looking at, we can just type out the summary function, and between the parentheses, we pass in the variable of the thing we want a summary of, the variable that holds that data that we need a summary of. So I'm going to go ahead and run this cell. This is the code in the chat that I came up with. And then everyone should be seeing these outputs. So please let me know in the chat or unmute if you're not seeing these outputs. So the questions were what column contains the highest median or the highest overall value. So we can take a look at the summaries here. We have for each column, we can see the minimum value, the first quartile value, the median value, the mean, the third quartile, the max. So if we take a look at the median values going across here, we see column 3 has the highest median value across all the columns, and it also has the highest overall value. Okay? Does everyone see how I got there? Is anyone not getting this output when you run summary? Perfect. Okay. Thank you. All right. Great job, everyone. Okay. So let's move on to data frame manipulation. So we've been talking about ways to read tabular data into a data frame structure. That's a specific data structure in R. Read it into a data frame. We hold that data frame in a variable, and then we can look at it in different ways. We can look at the dimensions. We can look at a mathematical summary. We can look at the first few lines. We can look at the whole thing. Now we can actually alter or change the data that's held in that data frame. We can run mathematical operations on it. We can merge data frames together, so on and so forth. So R, because it's a statistical language, makes it really easy for us to do that. And so I'm going to show you a few examples of mathematical operations that we can do on numerical data held in an R data frame. And these are going to come in handy later when we have our gene expression data held in an R data frame and we need to do some math with it. Okay, so the first thing that you can do, really easy, is add a value to all cells. So in R, since this language is designed to make it easy to do math, all you have to do is take the variable that holds your numerical data frame and say +1, and R will automatically add 1 to every value in the MyDF data frame. So let's go ahead and run this cell, and what you should see as output is the result of this mathematical operation. It's just printing out what it would look like if we added 1 to the data held in MyDF. So let's use the next cell to do a similar operation, but here we're going to subtract 2 from all the values. So I'm going to let you run that syntax, take a look at the output, and then put that syntax into a poll that I'm going to put up. Okay, great. So lots of right answers. The syntax is similar to MyDF +1, it's just MyDF -2. And if you run that cell, then you should be able to see a data frame that looks like this is what it would look like if we subtracted 2 from all the values in the data frame. Okay? Any questions on arithmetic with a data frame? Great. All right, so getting a little bit more complex then, we can also take the log of all values in a data frame. So there are several functions. There's just the log function, which calculates the natural log. You can also use the log10 function or the log2 function. So we can go ahead and run this cell that just, again, it's very similar syntax. We take our function and we pass in the variable that holds our data frame. So let's go ahead and run this cell. We should see what it looks like if we were to take the natural log of our data frame. So go ahead and use the next empty cell to do something similar, but compute the binary logarithm of all the values in your MyDF data frame. And then you can share that syntax via a poll. All right, I've opened the poll. So what syntax would you use if you can use log, open parentheses, mydf, close parentheses? What is the syntax you would use? And that calculates the natural log. What is the syntax you would use to compute the binary logarithm? And as a hint, the correct function is up here at the beginning of this section. All right, great. Thank you, everyone. Going to close the poll now. Nice, exactly. So all we have to do is log2 mydf, and that'll give us the binary logarithm because log2 is the function that computes the binary logarithm, and we're passing in the variable for my data frame. Perfect. Great job, everyone. Okay, so another cool thing that we can do is we can convert our data frame to contain only integers. We can round up to the nearest whole integer. And the reason that we're talking about this function is because there are several bioinformatics applications, including the DESeq2 method that we're going to use for differential gene expression, that requires that the input data contain only integers. So there's a handy function in R called ceiling, and that's going to round any decimal values up to the nearest integer. So we can just run this next cell that's already pre-populated to test the ceiling function. We're running ceiling and we're passing in one value. So let's go ahead and see what R gives us. So as you could see, ceiling, after we run this cell, ceiling of 1.2 gives us the whole integer 2. Now, we'd like to test this on a data frame, but our MyDF data frame, when we ran these log functions, we didn't actually change the data. We just printed out what it would look like if we took the log or the binary log, or if we added 1 or subtracted 2. So we never actually changed the data held in the MyDF variable. And we can prove it by using this next empty cell to print out the data held in the MyDF variable. And just double check the values are the same as what we started with. So we can just type MyDF again, we can print it out. So everyone should still see the very first data frame that we started with. Does anybody not see the original values? So row 10 should have 3 zeros, row 1 should be 1, 2, 3. This is the same data that we read in from the example.csv file. Does anybody not get this when you run just MyDF in this empty cell here? All right, great. So we haven't changed anything here, but we want to demonstrate the effect of running ceiling on a data frame that has decimal values. So let's create a data frame that has some decimal values. And so the way that we're going to do that is by running a mathematical operation, just like we did with the +1 or the -2, mydf minus 0.3. But we're now going to do something different. We're not just going to print out the results of this mathematical operation. We're going to assign the output of this subtraction back to the original variable name. So we're overwriting our mydf variable with this new data frame where 0.3 has been subtracted from everything. All right, is that making sense to everyone? So we're subtracting 0.3 from every value in mydf, and then we're assigning the output of that mathematical calculation using the assignment operator, a little arrow. We're assigning that back to the mydf variable. So we're overwriting the mydf variable. Okay? If this isn't clear to anyone, please let me know and we can review. But in the meantime, let's go ahead and run this pre-populated cell. So as you can see, when I ran this cell, there was no output. That's because when you assign something to a variable, it doesn't get printed out to your output, it gets stuck back into that variable. So unless there's an error, you shouldn't see an output when you're assigning something to a variable. So this is a good sign. If anyone got an error or a different output, please let me know. And so let's go ahead and use this empty cell waiting for us to print out the data held in this mydf variable that we've just updated. We've just overwritten with our math. So let's type mydf and run this cell to print out the data held in this variable. Have the values changed? They have on my end. So if anyone sees anything different, please let me know. But what I'm seeing here is a data frame that still has 3 columns and it still has 10 rows, but 0.3 has been subtracted from all of the original values. So what was 0 becomes negative 0.3, what was 1 becomes 0.7, and so forth. Okay, so we've now overwritten our mydf variable with a new data frame that has a bunch of decimals. So we can now demonstrate the effectiveness of our ceiling function. But first I want to make a note, which is here we overwrote the data in our mydf variable, which means we've lost the original data frame, which is fine, we didn't need it. But if you wanted to keep that original data frame and make a new data frame where 0.3 had been subtracted from everything, you could, instead of overwriting your original variable, you could assign the output of this mathematical calculation to a new variable name. For example, mydf sub or mydf subtracted. My data remain the same. All right, thank you, Kenesha. So did you run this cell that here, I'll put this in the chat. So the cell where we reassigned mydf to the output of mydf -3. So you did, and then when you print mydf, you still get a data frame that looks like this. It's odd. If you're comfortable sharing your screen, I am stumped. So it would really help me to be able to see. Or,
That's fine.
Yeah, okay, go ahead.
Can you see my screen?
Yes, I can. So it looks like something may have happened when you were running the cell that goes mydf arrow mydf minus zero point 0.3, because I should have pointed this out earlier, and maybe Amanda did and I don't remember, but when you run a cell, you see the brackets to the left of it, there should be a number there unless the kernel restarted or it didn't end up running successfully. So the fact that there's no number in those brackets makes me think something went wrong when you were trying to run that cell. So go ahead and run that cell that you have selected there, and let's see if you get a number. Perfect. All right, so now let's give that next one a try.
Okay.
Awesome. Okay, excellent. Yeah, so yeah, I should have mentioned that earlier. Cells that run successfully get numbers next to them, and cells that are in the process of running have a little star in the brackets. So that's how you can tell. Yeah, yeah. This was an easy one, thankfully. All right. Thanks. All right. There we go. Thank you very much for shouting out. Anyone else having an issue, please let me know and we can resolve it. Okay. So that was all right. Okay, great. So, yeah, so I was just pointing out, if you want to keep both your original data frame and your new subtracted data frame in two different variables, you can do that by running this math and assigning the output to a variable with a different name. That way, you'll still have your original variable in mydf, and then you'll have your updated variable in the new variable called mydf sub. Okay. All right, so now that we have our mydf variable, we've updated it, we've overwritten it, it now contains a bunch of values that have had 0.3 subtracted from them, so they're all decimals. We can use the ceiling function to round all the values in mydf up to the nearest integer, and assign the new values back to the mydf variable. So we're doing a second rewrite of the mydf variable, okay? So let me say that again. We're going to use the ceiling function. What we need to do is pass into the ceiling function the thing where we want all the values to be rounded up. So in this case, that would be our mydf variable that holds our data frame. But don't just do that. Run ceiling on our data frame and assign the output back to the mydf variable. Same way we did up here, where we ran some math and we assigned it back to the mydf variable. So it's very similar syntax, except here we're going to run the ceiling function on the data frame. Okay? So I'm going to give you guys a minute to figure out that syntax and share the syntax via a poll. All right, I'm going to close the poll in just a second. So if you still have an answer, make sure to submit it. Okay, closing the poll. All right. Great job. Great job, everyone. Nice. Okay. So lots of right answers. Let's go through this together. And if this is not clear to anyone, if you're getting an error, please let me know. So the first thing we want to do is use the ceiling function, round all the values of my DF up to the nearest integer, okay? So we used ceiling a little bit earlier on a single value where we just pass that value into the function. But you can do the same thing with a data frame, just like a dim or log or head, you just pass in the variable that holds the data frame and all the values will be rounded up to the nearest integer. So the first part here is to run ceiling on MyDF. You just pass in the variable that holds that data frame. But we don't want to just do that because this would just print out what it would look like if we rounded everything up to the nearest integer. We actually want to overwrite our MyDF variable by reassigning the output of ceiling back to the MyDF variable. So the way we do this is with that assignment operator and MyDF at the beginning of the assignment, okay? So I'm going to run this cell, put this in the chat. If anyone is not clear on how I got here, please let me know. But I can go ahead and run this cell. I shouldn't get any output because, again, I'm just assigning something to a variable, so nothing gets printed out. And then in the next cell, we can go ahead and print out the data held in the MyDF variable and how the values changed. What I'm seeing is, again, my 10 by 3 data frame, and all of the values have come back to where they were at the beginning when we read this data in from example.csv, because we subtracted 0.3 and then we rounded back up to those original whole integers. Is anybody not getting this when you run MyDF? Is MyDF not back to normal for anybody? All right, any questions about what we just did? All right, excellent. Mine is not back to normal. Okay. So even after running this code from the chat.
No, it's not. It's not.
That's okay. That's okay. Would you mind sharing your screen again?
No problem.
Thank you so much. If we were all in a room together, this would be really straightforward. I could come look over your shoulder and figure it out. Okay, let's see. Can you scroll up a little bit? Okay, all right. Okay, go back down. So that's good. That right, and that looks right. And then we subtracted 0.3.
Right.
And then we get MyDF and it looks all subtracted. And then we run ceiling and it has some negative ones.
Mhm.
Does anybody else see this? So let's see.
Did you by chance run the subtraction cell, the MyDF minus 0.3 multiple times?
Maybe once. Yeah. Yeah, that's what it does. Okay.
It must have just, yeah, it'll just do it over and over and reassign.
Okay.
So let's see. I think that this is, let's see. Okay, so what I'd like you to do, Kanisha, and anybody else who may also be seeing this, can you please rerun, just make a new cell and rerun this, like right wherever we are, yeah, right before slice a data frame column maybe. Make a new cell and rerun this, this cell, which is just going to read in the original data from the example.csv and get us all back to normal.
Okay, sorry. What am I running?
I just put it into the chat.
Okay, let me
Just the
go back.
last thing in the chat, yeah.
Let's expand. Chat. Sorry, I'm trying to go into the chat from my small screen here.
No problem.
Okay, that's you speaking. Wait, why can't I get into the chat? What? This is funny.
It's when you're sharing your screen, it is unbelievably difficult to get into any other part of WebEx.
So I see.
Now you see what Amanda and I have been dealing with.
Oh, that's what's been happening. Okay. Um, okay, no, that still minimize the screen. Okay. How do you get back to your chat?
If you go up to the top, like at the top of your screen, you should have like a little orange thingy, and if you hover over it, there's a bunch of options.
Oh, Jesus is right here. Chat.
And then
I'm
there's your
sorry.
chat.
All right, here we go. I was looking in the wrong place. All
Yeah,
right.
no worries.
Okay.
Okay, so stick that in your empty cell there,
Run
and then
this.
run that, and then run the next one. And let's just make sure we're back to normal. And
Okay.
great. Okay, perfect. So thank you so much, Kanisha. Really appreciate it.
Not a problem. This is gonna be most of your students.
No worries at all. So this is a really good, really good example of, R doesn't ask you what you think you're doing, what you actually want to do, right? It, yeah. So exactly as Amanda's saying, if we were to run this cell just over and over, we keep overwriting MyDF. So every time we run this cell, we subtract 0.3 from whatever MyDF was that time. So you subtract 0.3 the first time, you get a MyDF that has 0.3 subtracted from everything. You run it again, you subtract 0.3 from that new overwritten MyDF. So in essence, you've subtracted it twice. So, yeah, exactly. If you ran it 4 times, you would have subtracted 1.2 from each value. And then when you ran ceiling and it takes it up to the next highest integer, it's one less from everything we started with, which is what it looked like was happening to you. So when you overwrite a variable, you're overwriting a variable. So there's a reason why we put this syntax in here, which was kind of to talk about this lesson. Usually you don't or you think really carefully about overwriting variables for this exact reason. So when you're overwriting a variable, you can essentially overwrite it again and again and just redo that same command, continuously updating the data held in that variable. So this is a really good point. All right, so with that in mind, we should now be back to a data frame variable that has 3 columns, 10 rows, all zeros in the 10th row, and 1, 2, 3 in the first row. So just holler if you don't see that. But in the meantime, I'm going to move on to some more changes and manipulations that we can make to data frames. So the first one is something called slicing. So now we're getting into stuff that we can do with special characters in R that's not necessarily like a word and a function and parentheses. So this is a different type of syntax. So the first thing we're going to do is slicing, and one thing we can do with this slicing operator, which is the bracket operator, is we can slice out only one column from a data frame. And we can do that by name. So I've set up this cell below to slice out only column 1 of the MyDF data frame. So note that I take the MyDF variable, I do an open bracket, which indicates I'm starting to slice. I then pass in the name of the column I want to grab, and that name is a string. It's not a variable, it's a string, it's a set of letters that refers to one column by name. So I have to have it in quotes. If I didn't have it in quotes, R would think I was trying to refer to a variable called column 1, and I don't have a variable called column 1. So it would throw an error. So let's go ahead and run this cell together and look at the output. So the output of slicing out a column from a data frame is simply a smaller data frame with just that column. All the same rows, row 0 through 10, row 1 through 10, but just one column. Okay? So let's imagine that instead of looking at all the rows here of this, so we've printed out what would happen if we sliced out column 1. What if we wanted to slice out or subset MyDF to column 2? So that would just be this syntax, but you put column 2 in there. But only view the first 3 rows of the output using head. So remember, the way you look at the first 3 rows of a data frame using head is you pass in that data frame or a variable that refers to that data frame in between the parentheses here for the function head. So here, this syntax here is giving us a data frame that just has one column. So that's what you would put into the head function. Okay, so for this challenge, slice out just column 2 using this syntax, but pass that into the head function so that you can only view the first 3, and specify that you only want to view the first 3 rows of the output. So you might have to scroll up and look at where we used head before to look at the first 3 rows, or the first 8 rows of the output, okay? So I'll give you a few minutes to figure out this syntax and put it into the poll. All right, I have put a poll up for when you figured out the syntax to subset our data frame, MyDF, just to column 2, so that's using the syntax here. Then pass that into the head function and pass an additional argument to the head function to specify you only want to look at the first 3 rows of the output. Please feel free to shout out, put in the chat if you have a question about this, if you're getting an error, or you can just put I don't know into the poll and we can talk about it. All right, I'm going to go ahead and close the poll. Thank you, everybody. All righty. All right. Okay, so great job, everybody. This is non-trivial. And I see a lot of right answers and close to right answers. So let's walk through this together. Okay, so one thing at a time. We can just copy paste the syntax from up here to subset to column 2. Just change 1 to 2. All right, we know that's going to give us a tiny little data frame with just one column. All right, now we also know that the head function can receive a data frame and then can show, by default, it'll show us the first 6 lines, right? So we can run the head function on this tiny little data frame that just consists of column 2. We know that'll work because we know we can pass a data frame into head. However, we only want to view the first 3 rows of the output. And to remember that syntax, let's go back up here to where we learned about the head function. And recall that there's a second argument. If you can pass in a data frame to head, then you can add a comma and add a second argument, which is n, and you set that equal to the number of lines that you want to see, right? So we can do the same thing back down here where we were. We can add a second argument. We can add a second. Here we go. Okay. So we can, coming back right here, to our head function, we can add a second argument. The first argument is the tiny little data frame that's been subset to column 2. And we can add n equals 3 to only view the first 3 rows of the output. Okay, so I'm going to put this syntax into the chat and run this cell. So now we get our column 2 tiny data frame, and it's even tinier because we are only looking at the first 3 rows. Does anybody not understand how I arrived at this syntax? You want me to go over it again? Any questions? All right, cool. All right. This was quite a challenge because it kind of stitched together multiple layers of complexity on top of each other. Okay, so we can use very similar syntax to grab individual rows rather than individual columns from a data frame. That's again called slicing, and here we're slicing a data frame row. So again, we're going to use the bracket operator, but very tiny, intricate syntax. We just add a comma after the name of the row that we want to slice out. Okay, so the syntax goes again, the variable holding the data frame we want to slice, open bracket, the name of the row as a string, then a comma. So the only thing that's different here between slicing rows and slicing columns is that we add a comma after the name of the row. Okay, so I'm going to run this cell. So everyone should run this cell with me, and everybody should see a data frame that has been subset to the first row. Does anybody not see this? Okay, excellent. All right, so we figured out we can take a data frame, we can select a specific column, we can select a specific row. Cool. Now, we can also, instead of subsetting based on the name of a column or the name of a row, we can filter out data based on math having to do with the data frame. So, for example, we can filter out all rows that have 0 values. So this is a common thing to do in bioinformatics data. Often gene expression data is set up so that the rows are the genes. And so if you have a gene that was just not expressed in any of your samples, then that's just noise. We don't really care about that gene. We will see in a minute, we can also remove rows with where we're going to use, the way that we're going to do this is add up all the values in the row. So instead of taking out rows that sum up to 0, we can take out rows that sum up to some other small number, because that means that gene was really expressed at a low level or in only a few samples. So again, that's noise. So to facilitate this kind of bioinformatic filtering, we can use R to do some mathematical operations and select for those rows. So the first thing that we're going to do is we're going to calculate the sum of each row in our MyDF data frame using a new function called row sums, which does exactly what it sounds like it does. It takes the sum of each row. So all you have to do again is pass in the variable that that holds the data in our data frame and pass it into that function row sums. So let's go ahead and run this cell together. And as you can see, the output of the row sums function is the name of each row followed by a colon and the total sum across all columns of the values in that row. So as you can see, we have rows 1 through 10, and row 10 has a 0 sum. So we want to select or identify the next step in filtering out rows that have a 0 sum is to identify the rows that have sums greater than 0. So we can use the greater than mathematical operator, the arrow, to identify which rows have sums greater than 0. So this is just built-in syntax from R, because R is good at math, so it knows how to use mathematical operators. So we can take the output of row sums, which is this output that we see here, and we can interrogate it and say which of this output was greater than 0. So let's run this cell, and what you can see is the output of asking we're basically asking a question of R here. So the output of asking which row sums are greater than 0 here is a bunch of true false statements. So rows 1 through 9, true, yes, their row sums are greater than 0. And for row 10, it's false. All right. So finally, we can use this true false information to subset the MyDF data frame to remove all rows whose values sum to 0. So we're just going to use the same row slicing method we used above, but instead of passing in the names of rows, we can pass in this true false. So R will interpret this syntax as take my data frame and then slice it to only rows with sums greater than 0, knowing that the output of this row sum syntax with the greater than 0 is a bunch of true false. So R will only slice my data frame to the rows where the row sums greater than 0 was true, eliminating any rows where it was false. And again, we have to add this comma to tell R that we want to slice on rows, not columns. So let's go ahead and run this cell. And as you can see, if we slice MyDF on to take out any rows with row sums greater than 0, we've eliminated row 10. Okay. Now I just went through a lot here. Would anybody like me to repeat any of this? Is any of this not quite clear? Feel free to unmute or put in the chat. Okay, great. All right. So in that case, let's go ahead and see if we can do the next challenge question, which is if we can use this type of syntax to remove all rows with row sums not greater than 0, less than 0. Remove all rows in my DF whose sum is less than 20. So I'll give you a few minutes to figure out that syntax and I'll put it into the poll. Good. Let's see. All right. Lots of right answers and lots of very close to right answers. Okay. So let's think through this. I see everyone got inspired by the original syntax up here, which is great. So I'm just going to copy paste it here. So let's think through what this syntax is doing. Right? So we're basically asking R to take my data frame and only keep the rows that had sums greater than 0. That effectively eliminates any rows with row sums 0 or less than 0, right? So if we want to do the same thing with removing rows whose sum is less than 20, that means we want to keep rows whose sum is greater than 20. And this right here, we're slicing out and we're keeping any rows that fit this expression here. So we want to say keep rows with a row sum greater than 20. So I've just added a 2 here. And let's go ahead and run this and see what we get. So I'm going to go ahead and put this syntax into the chat. So we now have a data frame where we have eliminated or removed all rows with a sum less than 20 by keeping rows that have a sum greater than 20. Okay. R doesn't care if there's an extra space in the argument. No, R does not care if there's extra space, and I did it like this because I wanted to, this is kind of a pedagogical tool that I use to make it clear because there's so much going on here. So like this is one part of the argument, and then you also have to add the comma. So if you squish it all together, it's a little bit harder to see. But yeah, so this would work just fine if there were no spaces. But with spaces, yeah, R doesn't care. Good question. Yes, Mike, I did see your extra accurate answer. Thank you. So Mike is right that we can add an equal sign here to get anything greater than or equal to 20 to remove rows whose sum is less than 20. Thank you, Mike. All right. Any questions about this? All right. So let's talk about adding a column to a data frame. So this brings us to a function that I talked about a little bit earlier when I was showing you the appendix of all the different functions. And I told you that I sometimes want to name my variables A, B, and C. And there is a function called C, so that doesn't work. So sometimes when we're generating a table that has a bunch of results, we want to add a column, and that column might have some results from a different part of the analysis, and we just need to stitch them all together. So one thing that we can do here, we can create a fake column by just to demonstrate how you add a column to a data frame. And the way that we're going to create a fake column is using the C function. Again, this is a method. It combines all of its arguments to form a vector or a list. So I've put the syntax here where we create a new column, so we know any column we're adding to this data frame has to have 10 values because we have 10 rows. So I've just done 1 through 10 here. Then the way that you add a new column is by using the bracket operator that names a new column. So we don't right now have a column in our data frame called column 4, right? So we're saying we're creating a new column by using the brackets. So this is the same slicing operator, but we're not taking it out, we're putting it in now. And we're assigning to that column this list of values to create the new column. So let's go ahead and run this cell, and we see that we've added in successfully a new column called column 4 with the values 1 through 10. So I'd like everyone to please go ahead and I think this also might be the first time that I have 2 lines of code in one cell. So in case that it was not clear before, a cell in a Jupyter Notebook can accommodate more than 1 line of code as long as they are separated by lines. I mean, like they're on different lines. So our first command here was adding in column 4 using the assignment operator and adding in this new list that I made using the C function. And then the second command is now print out the new MyDF. I just put MyDF there and that'll print it out. All right, so you can have multiple lines of code, but they have to be on different lines. So now please use similar syntax to add a 5th column to your MyDF data frame and go ahead and print it out, same way I did here. Please share your syntax via a poll. And your 5th column can have anything you want in it as long as it's 10 numbers. Don't put strings or letters, and don't put more or less than 10 because we need to have 10 rows. It needs to fit in with an existing data frame that has 10 rows. Okay? I think I was muted when I was talking before. Yes, exactly. Running that cell runs both commands and one right after the other in the order they're listed. All right. I'm still waiting on a few more people to finish the poll. Are we getting really creative with the values that we're putting in our 5th column? All right, I'm going to go ahead and close the poll. Thank you. All right. Great. Perfect. Okay. Lots of right answers. So I'm just going to go ahead and do this myself. Column 5 instead of column 4. And I'm going to get really uncreative and just make my column 5 the same as my column 4. So you guys did great. So I can run this cell, and I now have an extra column called column 5. Very good. All right. So we're going to start in on the combining data frames section. We may not be able to finish it today, no problem. All right. So another thing that we're going to have to do when we're doing our bioinformatic analysis of the RNA sequencing data is we're going to have to combine multiple data frames, and we'll get to that. We'll see why, but sometimes we just have multiple data frames and we want to combine them together to make one big data frame, and we can do something with them. So there's a handy function. There are multiple functions in R that can do this. We're going to use the one called cbind, and this is a function unlike the other functions that we've just used, which can get away with only one argument if you just want to pass in one argument. Cbind requires at least 2 arguments because we're talking about 2 data frames being combined. So we have to pass in the names of the 2 data frames that we want to combine. So right now we only have one data frame. It's called mydf. So in order to demonstrate cbind, let's duplicate mydf and then use cbind to merge the original and the duplicated data frames. So in order to make a copy of mydf, we want to just take mydf and assign all the data in that variable to a new variable called mydf2. So we can, that's real simple syntax, just take mydf, use the assignment operator, and assign all the data in that variable to a new variable called mydf2. And then on the second line of this cell, we can print out what the contents of mydf2. So let's go ahead and run that cell. So you should all see a data frame that is identical to your mydf data frame. If anyone does not see this, please let me know. But it should be called mydf2. So we now have 2 data frames, mydf and mydf2. So we can go ahead and run the next pre-populated cell to combine them into one data frame. So we're going to run the cbind function, and in between the parentheses, we're just passing in mydf and mydf2, separated by a comma. And what we see here is the output. What's being printed to the screen is the output of binding together both data frames. So you can see here, columns 1 through 5, that's mydf, and then we have a repeat, columns 1 through 5 again, mydf2. All right, but all we've done here is look to see what would happen, like what would it look like if we combine these 2 data frames. We haven't like actually taken that data and saved it in a variable, right? So instead of just printing this out to the screen, let's go ahead and use the next cell to create a variable called combined df that holds the combined data frame. And we've made up this variable name combined df as a short representation of the phrase combined data frame. So let's take the output from this cbind command and assign it to a new variable called combined df. So I'm going to let you guys figure out that syntax and put it into a poll. All right, I've opened the poll, and what I'm asking for is the syntax that you would use in the next cell to create a variable called combined df that holds this combined data frame that we just printed out to the screen. So instead of printing it out, go ahead and assign it to this new variable. In the interest of time, I'm going to go ahead and stop the poll now. And then if we have questions, we can pick this up tomorrow. All right. Okay, so we what we did up here was we're using a new function cbind. We've passed in 2 arguments, the 2 data frames that we want to combine, right? Printed that out to the screen, but here, instead of just printing it out, we want to assign the output of this function to a new variable called combinedf. So I can just copy our cbind command. I can then use the assignment operator, the little arrow, and assign the output of cbind to a new variable called combinedf. And we can run that cell. So I'm going to put this to the chat. All right. So we will pick this up where we left off tomorrow morning. So everyone can save their notebooks where we are by pressing the floppy disk icon in the top left up here. And then you can export your notebook by going to File, Save and Export Notebook as an HTML, and then you'll be prompted to save it somewhere on your local computer. So that's File, Save and Export Notebook as an HTML. And I'll save the notebook that's completed up to this point. And then when you are done saving your notebook, please everyone make sure to stop your server. So go to Hub Control Panel, also under File, and click on Stop My Server. Okay? So File, Hub Control Panel, and then a new window will pop up. You can click Stop My Server, and then close the other window that you have open. You can close both of them. All right. Thank you, Joel.